All right, let's talk deployment. What does it take to take a beautiful, wonderful app that you have spent hours or days or weeks building in Node.js and get it deployed so that you can use it on the internet? Because that's the whole point, right? We build applications so that we can use them on the internet. So how are you going to do it? Well, let's get started by looking at an application that I already have running. So let's take a look. Here's the code. It looks like code. And if I open up the website, here's the website. It's beautiful, great, it works. I can add bands, I can delete bands, and that's, that's all that we really need right now. So there's other things that still need to be done to this app, but it's good enough that we can start talking about how do we deploy this to a live production real world environment onto the internet, and specifically how are we going to do this using Elastic Beanstalk. So the first thing we're going to do, this isn't entirely necessary, but I'm going to do it just because I always do it. It's good practice. It's a good thing to remember, is to make a Git repository so that you can track changes and roll back changes when you make mistakes. And the first thing that we need to do, I've already gone here and initialized the repository, but we have one big issue, which is this node modules folder. You don't want to include node modules in your Git repository just because it's a bunch of stuff that is easy to reinstall later. So we're going to create a git ignore file, add node underscore modules with a slash to that to tell Git, don't use the node modules file. And we're just going to use our little thing here, initial commit. And boom, done. Great. I don't need to publish it. This doesn't need to be on GitHub or anything. But now we have our code. It works. It's great. It's running. It does what we need it to do. So the first thing that we need to think about when we deploy to the real, well, there's a couple main things that we need to think about. The first thing that we need to think about is, how do we tell Amazon what we should be running? How do we tell Amazon how to run our project? And the way that we tell Amazon how to run our project is inside of package.json. What we need to do is add a little bit of information right here under the scripts, and we're going to say start. We're going to create a script called start, and we're going to say node index.js. All that is doing, that is how you run this project, and you're telling Amazon through your code how to run the project. So now I should be able, if I stop the project from running in my little terminal here, I should be able now to write npm start, and it will run my project. And as long as that's working, I've got my script set up correctly. It knows now how to run my project. Now, there's a couple other little tidbits of things that we need to change to make this ready for deployment. So one of those things we're going to fix right now, and that is this right here, the port. The issue with the port right now, it is set statically. It is set to run on port 3000. And that's great for running locally, and that's why when you start up your application, it's running on port 3000, just like you told it to run, and that's fantastic. The issue is, on AWS, maybe port 3000 isn't the right port. How do you tell it to do a different port? And the way that we do that is with a special set of instructions called process.env.port, and then we can put this OR here. So what this does is it tells Node.js when it is starting to look for what is called an environment variable. This is a variable that is set up in your operating system, or in your Linux operating system if you're in a deployed environment, and that environment variable is going to be called port. And that environment variable will specify what port our application should be running on. If there is no environment variable called port, then it will use port 3000. So I can double check here. If I Control-C and npm start, I can open up and see that just like before, my application is still running on port 3000. So nothing's changed in our testing and development environment, but we are able to change things in our production environment, things that we're going to need to change. Later on, we're going to fix this database thing here. But we're not ready for that yet because I don't know what the information is for the database that we're going to connect to. So let's take a look first at how do we get this code we know it's going to break because the database isn't set up, but how do we get this code ready to submit to Elastic Beanstalk so that we can have code up and running? And the way that we do that is by opening up our project in Finder or whatever you use, Windows Explorer if that's what you're in, and looking at the code that is there. So what we need to do is create a zip file that contains all of the code for our project, and that code needs to be at what we call the top level. So we can't look here at this, and on macOS you would right click and click compress. That's great. That's great for making a zip file to send to somebody else. Awesome. Unfortunately, that doesn't work in an Elastic Beanstalk environment because what needs to be at the very top level is this file called package.json that tells it how to run the application. So what we need to do is take all of the files that we want to send over, highlight those files, right-click on them, and on macOS you'd click compress. If you're on Windows, you would click something like, send a zip file or whatever that makes a zip file of those things. Now I'm going to rename this to be V1. I'm just going to call it V1. It's version 1 of our application, so we're going to make v1.zip. And you'll notice I did not zip up the node modules directory. For the same reason you don't include node modules in your code, in your Git repository, that's the same reason that we don't send those node modules with our project. You don't need them because the server can install those projects because all the things that it needs to install are listed right here in package.json. This specifies what our dependencies are. Package.lock.json specifies exactly which version of every one of those dependencies we have installed. So when we send this over to the server, this is exactly what's going to get installed on the server. The same versions that we have in our node modules directory right now on my computer, but it's going to install it itself so that we don't have to package up. Because if we look at this, if we look at the info for that, that's 14 megabytes. This can get ginormous. This directory can get huge, and we don't want to be passing that around if we don't have to. So we don't. Because if we look at the information for the zip file, that's only 20 kilobytes. Much better to send just our little 20 kilobyte of code and then have the server install all of those dependencies and other software on its own. So now we're ready to deploy version 1 of our application. So let's go over to AWS. So now that we've got our code ready to deploy-ish, it's time to do it. But you know what? Before we do that, let's commit our changes. Now you'll notice in VS Code or in Git that you now have a zip file that's being added to your repository. You don't want to add a zip file to your repository. That's what Git's for. You don't need to track previous versions of things. So let's add .zip star.zip to our git ignore so that we no longer get that zip file. We'll add the change to the git ignore and the other files and update port for deploy. We'll call that change. Now we are ready to hop on Amazon and do some deployment. So let me pull over Elastic Beanstalk in my Amazon dashboard. So we're going to open up Elastic Beanstalk in the Amazon dashboard, and you can see a couple previous environments here that I've been making as I test. When you pull this up, it's probably going to take you to this page. And what you want to do is click Create Application. And that's where we're going to start. So the way Elastic Beanstalk works is it creates an environment that is the set of software that you have installed, the operating system, the programming language, and all of those things. Because Elastic Beanstalk is a platform as a service, they manage the servers for you rather than you having to manage those yourself. So we're going to select a web server environment. I'm going to create an application. The application refers to my code. The environment refers to the stuff that Amazon manages for me. I'm just going to call it Node. You should call it something related to what this application is doing. In my case, well, you know what? We're going to call it Bands instead. Bands, because that's what this application does. And we're going to see Bands probably doesn't work, but if I make Professor S here, that works. I can make a professorS.useast1.elasticbeanstalk.com. That gives us a domain name that we can work with. And we're going to choose the managed platform of NodeJS, and you can see in that managed platform list other versions of software that you can install with Elastic Beanstalk. And we'll choose the 64-bit Amazon Linux 2023, leave the platform version as it is selected, and here we select to upload our code. We're going to choose a version label, we'll call it v1, and upload our v1.zip file. And that's what that's how we're giving Amazon our code so that they can run it. And we're going to leave this as single instance free tier eligible. If you want high availability, if you want to be running multiple instances across multiple availability zones within Amazon, you can do that. But in this case, we're just going to try and keep it as cheap as possible. Now we're going to go on to the next page. When that pops up, I'm going to pull over a little thing here. This here is instructions specific to the Amazon Learner Lab, the AWS Learner Lab. If you are working within the AWS Learner Lab, you need to select these specific options on this page. Specifically for the service role, under right here, you need to select lab role. Under the key pair, you can select VOC key if you want to maybe attempt to log into this server. And finally, under instance profile, you need to select lab instance profile as it specifies here. Once we're done with that, we're going to skip to review. And this just gives us kind of an overview of our settings. We haven't really changed a whole lot, so we're just going to submit, and that's it. Now we just wait for Amazon to set up our environment. So I'm going to pause the video here. We're going to wait for Amazon to do its thing, and then I'll come back. When we come back, we'll have a working, well, a halfway working application. And boom goes the dynamite. There we go. When we look at this, you can see we've got environment successfully launched. And if you scroll down here, you can see some updates that happened as the environment was created. So it created the environment, set up the storage bucket to put your code in, set up the security group, created the Elastic IP address, launched the instances, and did all of that stuff. And now we can click on our domain name for our environment, and so far we don't have certificates set up. That'll be something we set up later. Continue to the HTTP site, and there it is. I knew this was coming, so I'm not worried, but we have a connection refused. This is because, any guesses where this comes from? Any guesses where that comes from? If we look back at our code, at our index.js, right here, localhost 5432. That is Postgres. Our application is attempting to connect to a database running locally on its own machine, but that's not how Amazon does databases. You could do it that way if you created your own server, but that's not the best way to do it. The enterprise, the real world way to do it is to run the database on a completely separate server so that you've got those resources scaling independently. And so what we need to do now is set up the database. So let's do that next. And the way that we're going to do it is not a required way. There's many ways to add a database to your Amazon environment, but we're going to do it the easy Elastic Beanstalky way, and we'll talk about some of the options associated with that. So the way that we're going to make that change is make sure that our bands environment is selected right here. And then we're going to go to configuration. And you'll see it takes a second for the options to load up. And we're going to find that networking and database section, and we're going to click edit. And inside of there, there's a bunch of options, things that we could change, but we aren't going to. All we need to do is select enable database. And once that loads up, we're going to be able to select some options, relating to that database, and we can make that happen. First thing we're going to do is select Postgres, because that's the database that I like and I'm familiar with. Once that, again, reloads, we'll leave the engine version. This is the version of Postgres that you're using. We're going to select an instance class, and if you select a large instance class, you're going to get charged a lot of money. If you select small or micro instances, you're going to get charged a little bit of money for these database servers. So I'm going to select T4G Micro, because that is one of the cheaper services, and I'm not going to be using this for very much. Then we're going to select the storage. We're just going to leave 10 gigabytes. That's fine. We'll leave the username as it is. You can set the username and password to whatever it is that you want. I'm going to set the password here. We want to make sure that this password is secure and secret and complicated. I would suggest using only letters, capital and lowercase, and numbers. Not a requirement, but some symbols are not allowed in passwords on RDS. And so I just recommend just using letters and numbers because it keeps things simple. The last thing we're going to do is select the database deletion policy. This affects what happens when you're done with your Elastic Beanstalk instance or your Elastic Beanstalk environment. Let's say you're just doing this to play around. What's going to happen when you delete your Elastic Beanstalk environment? If we choose delete here, your database will be deleted when you delete your environment. If you choose retain, the database will stay around when you delete your environment. So it just depends. Are you using this to gather data that you're going to want to use later? Or if you delete this application, do you want the database to be gone too? I'm going to choose delete because when I'm done, I want it gone. You can also choose to create a snapshot that will save a snapshot of your database to be used later. That's maybe the cheaper option if you don't want to full on delete it, but maybe you want to be able to come back to this data later. But in our case, we're just going to choose delete. I'm going to click apply. This is going to create an update to our environment, and that's going to take a solid maybe 10, 15 minutes. So you're going to start to see events pop up down below. An environment update is starting. This is going to take a long time, so I'm going to pause here, and we'll come back when that environment is updated and created. Now we need to update our code. And how are we going to update our code? How are we going to tell our code to use the database that we are about to create? Once the database is created, we'll still have some work to do before we're ready to use the code, but let's take a look at that. And the way that we're going to do that is looking at the AWS documentation. Here on this Elastic Beanstalk, using features, using a database in configuring your environment, it has some information about how you can get information about your RDS, your Relational Database Service instance, into your application. And the way that we're going to do that is with environment variables, just like we did with the port. So let me move this to the side, and I'm going to open up my code on the other side. And we're going to make some changes here. So what we see down here in this documentation is that Elastic Beanstalk is creating environment variables for the various configuration pieces that we need in our instance. And so we're just going to go ahead and add each one of those right here. The host is going to be in a variable called RDS hostname. And if we want this to continue to work on our local machine, but also work in the Elastic Beanstalk environment once we've deployed it, we can access those environment variables with process.env dot and then the environment variable name. So in our case, host name, and then we're going to do the same thing we did right here with the port and offer this OR symbol and then the default value. So this means if there is a RDS hostname environment variable, we'll use that as the host. If there is not, we'll use localhost. Similarly with the user, that one is called process.env.rds username. And offer the option there. Password, process.env.rds password. The database, process.env.rds db name. And finally, process.env.rds support. Now, why are we using environment variables instead of just putting the password and the database name and the host name and all of that stuff directly into our code? Part of the reason is, like I said before, we want to be able to use this on our local machine and not have those environment variables set, but also on our deployed machine where those environment variables are set. So we want to be able to have both of those options, but there's other ways to do that. The main reason is that it's generally a bad idea to store some types of configuration that are machine specific in your code directly. So things like passwords, especially if you're putting passwords directly in your code, odds are you're doing something that you shouldn't be doing, because it's not generally a good idea to be putting passwords directly in your code, partly because if your code gets out, if you accidentally push it to a public GitHub repository, for example, that password is now accessible to everyone. So private things like passwords, even usernames, you don't want out in public, so we're going to use environment variables for those instead of publishing those more widely. So now, when we upload this new version of the code, once our database is created, once we upload this new version of the code, it should use these environment variables to set the connection information, and we won't get that error, connection refused error that we got before. So let's update our Git repository and say add db environment variables or something along those lines. We need to go back to Finder and zip up our new code. Now, long term, maybe you don't want to have to zip up versions of your code every time you want to upload them. And we can talk about ways to improve this process maybe in another video. But for now, we're just going to zip that up. Remember, don't zip up the node modules. Don't zip up version 1 of the code. Just zip up these files and create a file. You can call it whatever you want. I'm just, in this case, going to call it v2.zip. So now the environment has updated successfully. We can see it created an RDS database, redeployed my instances, and did all the stuff that Elastic Beanstalk is doing for me. Now I need to upload a new version of my code. So on this environment page, I'm going to upload and deploy version 2 of my code by choosing the file, selecting v2.zip, giving it a label of, I'm just going to call it v2, and deploy. And now we're going to wait. And every time this happens, the process is a little bit slow because the way that Elastic Beanstalk works is actually a little bit different than you might expect. So if you were doing this yourself, you would have one server, you would upload the new version of the code to it, maybe stop the old running application, start the new one, and be on your way. Elastic Beanstalk, in order to maintain those instances as cleanly as possible, Elastic Beanstalk, when you upload a new version of your code, actually creates a new instance with your configuration settings and all of those things, creates a new EC2 instance with the new version of the code, reinstalls the packages that you have specified in your package.json, and then switches over to using that new instance rather than using the old one. So we're going to wait for that to deploy, and then we'll check and see how things are working. Now that we've got our application up running, we can see that it is currently running version 2. Let's take a look and see how it works. Oh no, it's not working. It's broken. Why? What is broken and how do we fix it? We got a different error than before. Before we were seeing that it was error connection refused. Now we see error fatal 28 code 28,000 client authentication something something. This is all very scary things. So let's take a look at how do we investigate the source of an error and how do we fix it. First of all, we know we're using Postgres. We could possibly just Google Postgres error 28,000. But first I want to dig into a little bit more troubleshooting information that we have access to in Elastic Beanstalk. What we can look at is what is called the logs. And if we click on logs and go click over here to request logs and get the last 100 lines. I've already done this, as you can see, troubleshooting some things. but we're going to do it again, and we can see this is the time, this is the most recent one. So I'm going to click on download logs, and we can look here and find a section for, well, just find something that looks like an error message that you might want to see. And here we could maybe even search for 28,000 on this page, and we can see that there's something going on here. There's something going on, and we have additional information. So on our page, we got just this little tiny error message. Over here, we can see no pghba.conf entry for host. That's our IP address, user, blah, blah, blah. No encryption. Interesting. So we see that the database seems to be coming through. So our environment variables seem to be working. We're using the right user. We're using the right database. We've got the host. But encryption seems to be the problem. And further investigation on Google leads me to believe that encryption is our issue here. So how do we fix that? The reason this is a problem is because now that we are sending our database requests over the network, and not just within our local machine, but across a network, possibly even between networks, we need to encrypt those requests, because otherwise everything that we send is going to be unencrypted. That's bad. So let's figure out how to encrypt that stuff. And this is going to involve a couple steps. The first step is an update to our environment. So let's go back to our band's end environment. We're going to go to configuration, and we need to add our own environment variable so that we can configure this to, again, still work locally, but also work in our production environment. And the way that we do that is editing those environment properties. So we're going to edit that environment property, and we're doing the same thing that Amazon does for us automatically when they created the RDS underscore username environment variables. We just have the ability to do our own. And we are going to call ours DB SSL. The SSL is the encryption that's used. So we are just going to create an environment variable called dbssl, and we're going to call it its value. Wow, I am having a hard time typing. The value is true. We're going to apply that change. That is going to apply to our existing environment, but currently in version 2 of our application, we're not using it. But now we can update our code to use that environment variable. And the way that we're going to do that is right here inside of the connects settings. We're just going to set up this little thing, and look at that. Copilot's helping me out here, but I'm going to do a little bit fancier. I'm going to do process.env. What did we call it? dbssl. And then we need to do something a little bit weird, a little bit fancy. So we're going to use a different syntax. Rather than the or, we're going to use a question mark. And the question mark is JavaScript's way of doing a one-line if statement. So if dbssl is true, then the value is going to be reject unauthorized false. And what that does is sets this value of SSL to reject unauthorized false to this object if we need it to, and otherwise we're going to set it to false. So if dbssl is false, or if dbssl is not set, then we're going to use false. So this will continue to work in our local environment, but not in our, and also allow us to work in our production environment. So now we're going to add that. We're going to commit our change here, add SSL to DB, and we need to go back over to Finder, zip up our code, compress. I'll just gently move it down here. We'll call it v3.zip. And now that adding that environment variable has successfully deployed, we can upload and deploy version 3 of our application. I'm going to call it v3 and deploy. And now we'll wait for that to go through. Now our environment has successfully deployed. Once again, v3 is running. Let's click on Professor's US. Oh no. But it's always exciting when we get a new error, because that means we fixed the old one. So we have now fix the error with logging in, but now we've got this new thing, something about parser open table, and maybe we Google it, but you know what we're gonna do? You know what we're gonna do. We're gonna go back to the logs. We're gonna go back to the logs. We're gonna request the logs again to get a new updated version of the logs. I'm gonna clear these old messages, and now we've got our new version. Download the logs, scroll to the bottom, because these are in order. Some of these we're gonna see some old error messages, and you might see new ones. Okay, so here we have our parser open table. We have the error, select star from bands, relation bands does not exist. We're golden. Ooh, I can zoom in here and show that a little bit bigger. Error, select star from bands, relation bands does not exist. What does that mean? That means that our database isn't set up right. When you create a database locally, maybe you have database migrations, or maybe you've done this manually with SQL. In either case, we have a database that isn't quite set up the way that we want. So when we try to select stuff from that database, guess what? The tables that we are requesting from, like bands, do not exist. Now we need to create those tables. So how do we connect to those database instances and create those tables? That's our next step. So we've identified what the problem is. How do we fix it? The good news is it's fixable. The bad news is it's going to take a little bit because we've got some stuff we got to do. So let's take a look. The first thing that we need to do is be able to make changes to our RDS, our relational database service, our Postgres server that is running on Amazon's cloud. And how are we going to do that? We need to go to RDS. We need to find our RDS settings and maybe make some changes there. So we are going to go to RDS by typing it up here in the bar. And find database instances, DB instances. We need to click on that link, and this gives us information about our database. Now that we've got some of that information, let's click on there. We've got a database identifier, and look down here, we've got all sorts of information. We've got a host name. Well, so now we need to access this database. And how are we going to do that? I'm going to do it using pgadmin. Pgadmin is my favorite Postgres server access tool. And I am going to just go ahead and register a server. And I'm going to call it Node RDS. You call it something useful that resonates with you and helps you remember what it is. And let's go over to connection. We're going to specify our host address. And that host address is the endpoint that's specified here in our settings. The port is 5432 because that's the default. We remember our username is ebroot, and our password is whatever password was that we specified. I'm going to put that there. I'm going to check the save password box. And now we are ready to connect, except for one little thing. Elastic Beanstalk, and well, Amazon likes to get you on this. It likes to, set up secure things. It likes to set up secure rules to keep your information safe. And it set up the security group rule, and if we click on the security group, we can see that the inbound rule only allows TCP 5432 from this same security group. And essentially what that means is it's only going to allow traffic to come from very specific hosts, because you don't want your database open up to the whole world. You don't want random people to manage to guess your password or brute force your password and log in. That's bad. So they're going to limit access probably only to our Elastic Beanstalk instances. So we need to change that, and we need to edit the inbound rules to allow traffic to come also from somewhere else, probably your IP address. So what am I going to do? I'm going to set up PostgreSQL port TCP port 5432, and you know what? I'm just going to do it this way: TCP port 5432, and I'm going to use my IP address. I still don't want to open this up to the whole world. I just want to open it up from my specific IP address so that I can access it from my machine. And once I make that change, give it 5 or 10 seconds to go through, and I can make the connection. And now I have access to a remote Postgres database. And I can look and I can see that EBDB is there. And I want to make some changes to EBDB because remember, that was the database that was created for us. That's the database that we want to access. So I'm going to click on the query tool, and then I'm going to paste in my SQL that creates that database that I worked so hard to create. First, I'm going to create the table bands, run that, query completed successfully. Then I'm going to create the table songs, execute that, query completed successfully. And so now the SQL has been run on our database in RDS, so those tables should exist. And if I just go back to this page and refresh it, look at that. I'm going to zoom out just a little bit, but it's working. It's here. And now I can add my bands again. Save, and all of it's working. We now have a fully functioning site on Elastic Beanstalk that is talking to an RDS database in the cloud. You have a website running on the internet for the whole world to see. Great job.